Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video details the methodology for deciding proportion hypothesis tests and explains the proper use of confidence intervals in conjunction with the hypothesis test. Let's get started. So we can decide hypothesis tests on proportions in one of two ways. First, we can compare the test statistic with the critical value, or we could compare the p-value with the significance level alpha, or if we have a two-tailed test, we can construct a confidence interval at the 1 minus alpha confidence level. This is why I said 2 to 3 ways, because you've got 3 ways if you've got a two-tailed test, but only 2 ways if you've got a one-tailed test. So when we're testing a claim about a proportion, just like we've seen previously with hypothesis testing, you're going to get the same result whether you use the test statistic with the critical value or the p-value with the significance level of alpha. You're going to get the same result out either way. However, the confidence interval gives you an estimate that sometimes gives you a result that's very different. So you're going to lead to one conclusion with one of those ways, the formal hypothesis testing, but then the CI will give you something completely different. And so that's why there's a restriction on the confidence interval. And typically, we're not going to use confidence intervals when we're dealing with hypothesis testing of proportions, because to test a formal claim, we're just going to use the hypothesis test, because it's a lot more sure than the confidence interval itself. However, we are going to use the confidence interval to give us an estimate of the population proportion. So the value of that population proportion is fairly reliable from the confidence interval. So we'll get the value from the confidence interval, but then if we're going to test a claim, we're going to go with the hypothesis test and not the confidence interval. Let's go back and look at our previous example where we were looking at antivirus software, and this was from the previous mini lecture. So we had a two-tailed test with a test statistic of z equals 1.57. So if we're using the p-value method to evaluate our hypothesis test, how do we do that? Well, we don't have any actual formal stats here. All we're given is that we've got two-tailed test with a test statistic. And in that case, we're going to have to go into the normal calculator and stack crunch to get our answer out. We can get the area in one tail by getting the z-score in. So I got the area here in the right tail, but I'm a two-tailed test, so I know I'm going to have an area of equal size here on the left. So I just take this area that I get, 0.0582, multiply it by 2, and that gives me 0.1164. The other way to do this is to use the between option there in stack crunch in the normal calculator and get the area in between the tails. But notice the area in between the tails is the confidence level. I want the actual area in the tails themselves. So this area that comes out, I'm going to have to take 1 minus this area. I'm going to take the complement in order to give me the actual p-value. But either way you work it, you're going to get the same number to come out. So there's your p-value method. And because the p-value is much greater than the significance level alpha, we're going to be outside the region of rejection, and therefore we fail to reject the null hypothesis. We can reach the same conclusion with the critical value method. So again, in the normal calculator there in stack crunch, if I'm selecting the between option up at top, I can find the critical value, the 1.96, by putting in the confidence level here into my area. So I know if alpha is 5%, that means 5% is in the tails of my distribution. So I want 95% in between. And the boundaries for my critical region, or the region of rejection, is going to be here, as you see, plus or minus 1.96. So if I compare that with the actual test statistic, I see that the test statistic actually falls in this central region here, where I fail to reject the null hypothesis. So I'm outside the tails, outside the region of rejection. Therefore, I fail to reject the null hypothesis. Just as we saw with the p-value method, we get the same result. So either way you work this, you're going to get the same thing out. Now let's take a look at our confidence interval. So for this particular problem, we're testing the claim that the population proportion is 93%, and we're doing this at the 5% significance level, which means we have a 95% confidence level. So first we're going to calculate our margin of error. This is our margin of error equation. As you may recall, when we were looking at confidence intervals on proportions, we plug in the values that we have. Notice that the p-hat value that we're getting here, 95%, that's coming from what we saw in the previous mini lecture, where our sample proportion 95%, which means the proportion of failure is going to be 5%, and then we're going to have 400 as our sample size because there was a survey of 400 computers. So we punch those numbers out in our calculator, and out comes 0.021. We're now ready to construct our confidence interval. Here's the general form for the confidence interval. We're going to add and subtract that margin of error to our sample proportion, which was 95%, and we get a lower bound of 0.929 and an upper bound of 0.971. So, because our 95% confidence interval contains our claimed population proportion, the claim is that it's 93%, that's actually inside the confidence interval. That's the region of rejection, so we're going to reject the null hypothesis. Well, the conclusion from the p-value and the critical value that we saw earlier was just the opposite. We failed to reject the null hypothesis, and so there's not sufficient evidence to warrant rejection of the claim. And this is why we're not going to use confidence intervals when we're testing claims about proportions, because more often than not, you get something different from the confidence interval than you get from the more formal methods of hypothesis testing. So we're going to use hypothesis tests and that formal method to test the claim about a population proportion, but to get the actual value out, we're going to be using a confidence interval to estimate that. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.